All right, so this equation, basically these three things multiplied together they equal these three things multiplied together. And what these things are, the H plus, that's just the number of H's you have in your acid. So for example, HCl only has one H, so there's just one H plus. And the H plus, it's just to like acids and bases when they're, when they react or when they're put in water, they will, what's the word? I think it's called, they ionize. They just split up. So it'll have a charge on it. It's an ion. But anyway, yeah, you don't really need to know that. All you have to know is how many H's there are in the formula. So this volume of acid, typically given to you in milliliters, and yeah, it's pretty basic. Molarity, I'm sure you know what that is. Moles divided by liter. It's just how concentrated something is. And it's just really a value that we're using to multiply or finding in these set of questions. Volume of base, again, in milliliters for these questions. But if you ever get something different, like if this one's in milliliters and this one's in liters, you just have to convert them to be the same units. But yeah, don't worry about that for these questions. Molarity again. Oh, and I'm pretty sure the B's and the A's, just because this is the acid side and that's the base side of the equation, it's just to help you tell them apart. And again, for this, number of OHs in your base. So for NaOH, there's only one, or for like CaOH, there's two. So we just have to account for that. I think it'll kind of make sense once we start to do the problems. So how to solve the problems is basically I'm just going to fill out everything I can, everything I have in this equation. And there's only going to be one thing missing, and that's what I'm finding. And in the problem too, it tells you what you're finding sometimes. So I have 82.4 milliliters of HCl. Oh crap, I have to start with, I guess it doesn't really matter the order, but so again, I only have one H, so that's just one H plus. So yeah, and then for, so it's 1 molar HCl, and that's just given to you, and then we know it equals, so I wrote that kind of weird, but given 20 milliliters of NaOH, and we don't have the molarity of the base, so that's what we're finding. I'm just going to keep that as MB. It's like a little variable. And then we only have one OH. So, yeah. Alright, and then, let's see. So, we're just trying to find this, so we solve it kind of algebraically. We just divide everything on this side that's not the variable. And then we do the same to the other side, because it's an equation. Yikes. Alright. So then we just solve this. I know it's kind of hard to read. Sorry. So, just to make things simpler, I'm not going to times things by 1, but you will have to kind of incorporate those values if they aren't 1. Does that make any sense? Just like, I'm not going to times it by 1 because it's the same. So basically you just have 82.4 milliliters divided by 20 milliliters. because everything else is 1. So we get our answer. And again, these units, they will all cancel. And I guess these cancel too somehow. Just because like they're kind of the same. They're basically like moles. But yeah, don't think about that. Just think about this equation. So yeah, that's our answer. And because our units all canceled, we're just left with this unit. So it's in molarity, that's correct. You don't really have to think about that. We already know that we're finding the molarity of the base. So yeah, we found it. That's your answer. So number 2, if 65 milliliters of 0.15 molar H2SO4 used to neutralize 144 milliliters of NaOH. I wrote that terribly. So again, just fill out all the information you have and solve for what you don't. So H2SO4, there's 2 H's, so 2H plus. And we have our volume of our acid, it's 65 milliliters. And then our molarity of our acid, it's given to us, 0.15. Then the other side, volume of our base, 144. Let's see. Oh, we don't have molarity, so that's what we're finding. And I'm pretty sure that's given to you in the question. So just leave that as a variable. And then we only have 1 OH, so just 1 OH minus. And then again, same thing. We divide everything on this side that's not the variable, just like in algebra. Yuck. Sorry, that was cringy. One OH. And again, like, that will cancel, that will cancel. Then we just multiply this out. So I'll do 2 times 65 times 0.15. And then we divide by 144. All right, and so I just kind of look to see how many digits there are in like another molarity, or it's just because like this only has 2 digits, that our answer can only have like 2 digits because of sig figs. So I'm going to count that as 0.14 molar of NaOH, because that's what we were finding, the molarity of the base. That's our answer for that one.